Viewers, welcome to the YouTube channel H2O Chemistry. In our last few videos, we have been watching the concept called periodic properties. So far, we have covered atomic radius, ionic radii, ionization energy, and electron affinity. In this video, I'm going to talk about the concept called electronegativity. See, let us imagine a non-metal. We know that when metals and non-metals, usually it makes ionic bond. So when a metal and non-metal reacts, metal and non-metal reacts, it's make ionic bonding. So transfer of electron takes place from metal to non-metal. What about if non-metal reacts? A non-metal reacts. So this is an idea you should know, because metal having the tendency of losing electron, whereas non-metal having the tendency of gaining electron. Here both the atoms has the tendency of gaining electron, gaining tendency. So this kind of elements makes covalent bond. So this is the first idea you should know. Okay, covalent bond. Now let us consider the case hydrogen. One more hydrogen. The atomic number of hydrogen is 1 The electronic configuration also 1 in case shell. It has a 1 proton, 1 electron. It also has a 1 proton, 1 electron. Right. So this is an electronic basic idea. Now, when this is also non-metal, this is also non-metal. When these two non-metal atom bonded to each other, what happens? So we already studied the Lewis dot structure. Lewis dot structure, we will write for this. So Lewis dot structure mention only the outermost electrons. For the hydrogen, it has only 1 electron. So the Lewis dot structure is like this for both the hydrogen. The K shell is the K shell of the hydrogen has only 1 electron, but the maximum capacity is 2. So when the two atom shares this electron, what will happen? Both the atom will have a 2 electrons like this. So this is before combination, but after combining, the bond will be formed. So the bond will be formed like this. So this is a bond, right? So the bond will be formed like this between the two atoms. Now you could see clearly the hydrogen, the both electron belongs to this hydrogen atom as well as for this hydrogen atom. So this is an idea. Now this kind of sharing, mutual sharing of electron between the two atoms is called covalent bonding. The covalent bonding, this also has a 1 proton, this also has a 1 proton. So this hydrogen atom pulls these two electrons with the same power like this atom, because this also has a 1 proton. So in this kind of covalent bonding, the bonded pair of electrons lies exactly in the middle of a bond. So middle of the bond you will find the electrons. So this is the first idea you should know. So when there is an equal protons, the pulling power of the atoms is equal. So this is we call shared pair of electron, because this is used for shared pair of electron or bonded pair. So both are correct, bonded pair of electrons. So this bonded pair of electrons are lie in the middle, because both atom has the same power of attracting the electrons, bonded pair of electrons. So this hydrogen also attracts in the same power like this hydrogen. So the electrons are in the middle in the bond. what will happen if the bonding happens between the hydrogen and a chlorine? This is what another question. Hydrogen and a chlorine. The atomic number of hydrogen is 1, whereas the chlorine is 17. Right? So the electronic configuration, if you see, for hydrogen is 1, whereas chlorine is 8, 2, 8, 7. The hydrogen has a 1 proton, 1 electron, whereas chlorine has a 17 proton and 17 electron. So look at this. Hydrogen also have a 1 electron short to fulfill the shell. Here the chlorine also has a 1 electron to short to fulfill the shell. Only 1 electron is less to fulfill the shell to become 8. Now in this case of hydrogen, both the atom acquire the configuration of helium. So this is because only 2 electron we have for the both the atoms, so the acquired configuration is helium. Now if the hydrogen gains 1 electron, it will become the configuration of helium after gaining, whereas the chlorine will gain the configuration of argon if it gains an electron. But both the atoms have 1 electron less than the nearest noble gas configuration. So these two atoms can share its electron to fulfill the last shell. So like this, let us like the Lewis dot structure again. Lewis dot structure. In this, hydrogen has 1 electron, chlorine has a 7 electrons. So 1, 2, 3, 4, 5, 6, 7. So let me draw it in different colors so that it will be easy for you to distinguish. So the red one is for hydrogen, the black one is for chlorine. Now when these two shares electron, what will happen? It will make a bond. So this kind of sharing also is called covalent bond, right? So now the hydrogen shares this electron, chlorine shares its particular electron, so remaining all are as it is. Now it makes a bond. You could see it makes a bond by using these two electrons. Now this kind of bonding is called covalent bonding. Now look at this helium, hydrogen, and this chlorine. Both the atom acquires stable electronic configuration. Now if you write the number of electrons in hydrogen, we will write 2 electrons, whereas here we will write 8 electrons. So the hydrogen has acquired the configuration of helium, whereas the argon has attained the configuration of argon, right? So this is an idea. Here what will happen to the electrons, bonded pair of electrons? That's what my question to you. So in this case, both the hydrogen have a same power of pulling. So the bonded pair of electron exactly lie in the middle. What about in this case? That's what the question. This question will answer the concept of electronegativity. So this is the idea, my dear children. We have to see to look at the concept of this electronegativity. So from this, what you have learned is, here the hydrogen has a 1 proton, here the chlorine has 17 proton. This is another important criteria we have to see. Got it? So now we will see this portion. Got it? Now look at here, the hydrogen and electron is here, the chlorine electron. So we have like this, so it makes a bond. My question is where these 2 electrons goes, whether it should lie in the middle or else pulled towards something else. The answer is very simple. The hydrogen has a 1 proton, whereas the chlorine has 17 protons. So the proton, if you look at it, the chlorine has a more pulling power. Am I right? The chlorine has a more pulling power. So when you look at the bond, the electrons are pulled towards chlorine atom. The electrons pulled towards chlorine atom. So that's what we say. The chlorine is the highest electronegative element. So it pulls the electron. What electron? Bonded pair of electron towards itself. Then the hydrogen. So it is less electronegative compared to chlorine. Here I told you the negativity is a relative property, because we are comparing the hydrogen and chlorine. With the comparison of hydrogen, chlorine has the most pulling power here. Chlorine has the highest pulling power, so it pulls the electron towards itself. Right. Now, what will happen to the chlorine? That is another important question. Let us see what happens to the chlorine. Now, what happens? For the chlorine, bonded pair of electrons comes closer to the chlorine. So, what is the charge of electrons? So, the bonded pair of electrons lies here. So, this is a picture we have seen. Look at this cloud. The electron cloud moves towards chlorine. So, this side has a partial negative charge. Whereas here, hydrogen somewhat lost its electron, somewhat, not completely, somewhat lost its electron. You could see this area, the electron is less in this area. So, what happens? The hydrogen has partially have a positive charge, because it has lost somewhat, not fully lost, but it has lost somewhat. So, when this happens, when the hydrogen chlorides reacts in any reaction, what happens? The bonded pair of electron is mostly taken by chlorine. So the hydrogen electron, along with the hydrogen electron, chlorine goes as Cl minus, and hydrogen loses that electron. So whenever the reaction occurs, got it? The chlorine has the highest electronegativity or highest attracting power of this bonded pair of electrons when compared to hydrogen. The chlorine, whenever the bond breakage happens, whenever the hydrogen chloride bond breakage happens, the chlorine always take up the electron to become a chloride ion. The hydrogen loses the electron to become a hydrogen ion. This is what you have to understand, my dear children, very clearly. Now, in this example, I'm going to explain this electronegativity concept. So what you understood? There is a difference between the electronegativity of two atoms. Even though both are non-metal, the pulling power of chlorine is different from hydrogen, or else higher than hydrogen. The different power of chlorine, the pulling power of bonded pair of electron of chlorine is higher when compared to hydrogen. So when there is a difference in the electronegativity, we get the partial charges like this. So the partial charges usually written in the letter called delta. This side is plus, delta minus this side. So the delta means partial. Delta means partial charge that is created. That is the first idea you should know. So what is the definition of electronegativity? You know that definition. What is the definition of electronegativity? Here, one atom pulls the bonded pair of electron towards itself. Right? So can I say it is a tendency of an atom? So it is a tendency of an atom. It is a tendency of an atom to attract the bonded pair of electrons, towards, so bonded pair electron towards itself. In a what kind of bond? It is a covalent bond. Towards itself in a covalent bond is called electronegativity. So it's called electronegativity. Electronegativity is sometimes usually called it as a En value they call. I told you it is a completely relative property, right? What will happen if the two chlorine atoms shares these electrons? This also has 17 proton, this also has 17 proton, so the electrons lie exactly in the middle, so there is no problem. So in this case there is a equal electronegativity elements bonded each other, so the electrons lie exactly in the middle. Whereas when there is a difference in electronegativity between the bonded atoms, there will be a partial charge like this. This is what you have to understand. So this is the definition, my dear children. So all this explanation for this electronegativity to understand the concept. If you understand it clearly, you will not forget it. So when the similar atoms bonded each other, there is no difference in electronegativity. The bonding is, there is no charges created. Here charge is 0, here also charge is 0 in hydrogen case. What about here? Here we have a partial plus charge, here we have partial minus charge. So what you understood? When there is a difference in the attraction power of a single atom, of an atom, creates its partial charges, this tendency is called electronegativity. This tendency is called electronegativity. Okay then. Next, what else we have to understand? See, this electronegativity concept, this electronegativity value, this electronegativity value depends on many factors. The first factor is bond dissociation energy. That means when the bond, what is the energy required to break this bond? So that bond energy is called bond dissociation energy, we call. So when the bond of HCl broken, we need to supply some energy, right? So that energy is called bond dissociation energy. So the electronegativity is depends upon this bond dissociation energy. Next is ionization energy. Why? Because once the bond is broken, one goes as a plus, another end goes as a minus. So it creates an ionization energy, right? It acts like the H hydrogen acts like ionization energy. You just look at this process. This forming a cation. So it is IE process, ionization energy. The next one, electron affinity. Affinity. Look at the other one in the reaction. Here you look at this. So when the bond breakage occurs, the chlorine actually forms an anion. It is nothing but electron affinity process, EA process, right? And also this is depends upon nature of the atom in which it is bonded. It is bonded. So what is meant by nature of the atom? What is bonded with the atom? That means here chlorine is bonded with a hydrogen or one more chlorine. If a chlorine is bonded with one more chlorine, there is no partial charges because electron lie in the same place, so the partial charges will not create here. So when there is a nature of atom differs, then only the electronegativity plays a major role. You have to understand this. So these are the point you should remember. So I told you it's a relative property because we are comparing the electron negativity of hydrogen and chlorine and we are talking. So we are comparing with the other atom, then only we can call, that's the reason it is called relative property, and all the other periodic properties are not relative property. That you have to understand. The next one, that is a scale to identify this electronegativity. Scale we call electronegativity scale, right? The scientist who gave this scale is called Pauling. Pauling. So this scale is called Pauling scale. Pauling scale, right? So the Pauling scale, he has given, he has predicted the value for elements, value for the electronegativity for the particular element. Let us see the first group elements. In this we can say hydrogen, lithium, sodium, potassium, rubidium and cesium. The hydrogen has the electronegativity of 2.1, lithium has 1.0, and sodium has 0.9, and potassium has 0.8, rubidium has 0.8, and cesium has 0.9. So, right? So he has predicted the electronegativity value based on the uh, bond dissociation energy, ionization energy, electron affinity, and nature of the atom. By using this, he has calculated the electronegativity value of hydrogen is 2.1, lithium is 1.0, right? So these are the value he's predicted. Look at this last one. We'll come back to this later. Now look at this next one, that is along the particular period. Beryllium, boron, carbon, nitrogen, oxygen, fluorine. In this case, beryllium, right? The beryllium has 1.5, and the boron has 2.0, and carbon has 2.5, and nitrogen has 3.0, oxygen has 3.5, and fluorine has top number 4, and chlorine again 3.5, bromine, right? So it goes on like this. Bromine 2.8, and then iodine is 2.5. So look at this cesium and this fluorine. In the Pauling scale, the fluorine, out of these all elements, fluorine has the highest number. So the electronegativity of En value of fluorine is high. Got it? This is 4.0. Come to the cesium. The En value of cesium is low. So in the periodic table, which has a highest electronegativity value according to Pauling scale is 4, fluorine. Which has a lowest En value is nothing but cesium. So this is you have to understand. And one more information, with this value Pauling has identified. So what is the use of this electronegativity? We can say application of electronegativity. What we can see, we can predict. It helps in the prediction of nature of bonding. Got it? So what he said, three type of conditions. One condition is if the difference in the electronegativity value you have to consider. Difference in electronegativity value we have to consider. If you consider, if the difference in En exactly equal to 1.7 and difference of difference in En is less than 1.7 and difference in En greater than 1.7. So if I talk about an example, you will understand more about it. Let us talk about the bond in the sodium chloride. So sodium is plus, chlorine is Cl minus. Here, what is the En value of the sodium? You look at this Pauling scale, 0.9. Whereas this chlorine is 3.5. What is the difference between these two? So 3.5.9. So it is 15.6. Here 2, 2.6. 2.6 is the difference between the sodium and chlorine. So if the bond is, it's greater than 1.7. If the difference is greater than 1.7, the bond is ionic. Very simple idea, you could see. Now let us calculate for the hydrogen and hydrogen. Very simple, right? What is hydrogen? So 2.1, again 2.1. The answer is 0, right? Answer is 0, which is less than 1.7. Am I right? So 2.1, 2.1. Hydrogen 2.1 is the value. You could verify here. So the answer is 0. So it's less than 1.7. So the bond is covalent. See how easy it is to find out. Right? Now let us go for this hydrogen chloride. Hydrogen is 2.1. Chlorine is 3.5. So 3.5, 2.1, 4, 1.4, which is again less than 1.7. So it is again covalent. So the bond is covalent. See how easy it is. If the difference in the electronegativity is exactly 1.7, the bond is 50% covalent and 50% ionic. This is what you have to understand. So this is the application of electronegativity, my dear children. Got it? Got it? So this is small information, but it's a very good idea to um, remember. Now we will give some more examples so that you can work out. Now look at the first one. Find out the electronic difference of NaBr. Second one NaI. Third one NaF. And the fourth one NaH. Fifth one LiBr. And sixth one cesium iodide. So you practice this sum, my dear children. NaBr, NaI, NaF, NaH, LiBr, cesium iodide. So you just take the value from this table, and then if you find the difference between the electronegativity value of these two, if you find this which is equal to 1.7, so that I can predict the bonding nature is 50% covalent, 50% ionic, then the difference less than 1.7 means which is covalent. It is more than 1.7 means it's an ionic. The bond is said to be ionic. This is what the understanding, my dear children. Hope this video is very helpful in finding the electronegativity definition and the factor which is depends upon, and then the scale we call Pauling scale, and how to calculate, and this applications of electronegativity. If you like this video, subscribe and click the bell button to get the notification instantly. Like, share and comment. Thank you.